All right, so now we know how to go from moles to particles, moles to grams, moles to liters. Three different ways of converting moles. Well, what that now will allow us to do is convert moles and something else, or in other words, multi-step conversions. I really like this little flow chart. Basically what I've got here is I've got my moles in the center, okay? And I can go from moles and mass interchangeably, okay? And again, the conversion factor is from this unit equality. 1 mole is, you got to look on the periodic table to see what it is, okay? If it's water, you add the H's and the O. If it's lead, well, it's just straight lead, 207 grams per mole. So that's where you get that. We also have moles and particles. We can go from particles to moles or from moles to particles, all right? And again, that one is just your 1 mole is 6.02 times 10 to the 23rd particles, your Avogadros, okay? And the last one we saw was our conversion between volume, of course at gases, at STP, volume, liters and moles. And that one is, 1 mole is always 22.4 liters, okay? So obviously now, if we're giving mass, if you're given a mass and you want to know how many particles, you want to go to particles from mass, then basically you have a multi-step conversion. Yes, you can go directly from mass to particles very simply. I'm a much bigger fan of using the moles as our hub. So we would go from mass to moles, then we would go from moles to particles. In essence, that's kind of what I did when I had my graduated cylinder of water. If I have 18 grams of it, right, because I have 18 milliliters, 18 grams, then I have 1 mole of it, and then I would have 6.02 times 10 to the 23rd molecules of it. So I kind of converted when I talked about that. But really, let the X line tell you how to do it. And I really like going to moles as a hub, as a center, every time I do any kind of multi-step conversion. So let's take a look at an example. Let's say I have 101.4 liters of carbon dioxide, okay? And I want to know how many grams of carbon dioxide that is. Okay, so I have my liters of carbon dioxide and I want to know how many grams. Now, again, I always say before you get in a car and go somewhere, you should know where you're going. Whether that means, even if you're just going for a ride, you should know, am I going to take a left out of this driveway, or am I going to take a right out of this driveway? What am I going to do? So here I like to think about this little flow chart. So let me just draw that flow chart. Moles, I have grams conversions, I have particle conversions, and I have liter conversions. Now, I'm not even talking about liters in this case because, I'm not even talking about particles because I'm giving you liters right here and I'm asking for grams. So thinking about which way you're going, getting in your car and driving, you're going to convert to moles. And again, I'm a big fan of always going to moles and then from moles to particles. So we have 2 steps in this multi-step conversion. The first is going to be to moles from liters and then liters to grams, okay? And then from moles to grams. So there's my flow chart. That's kind of the idea. Let's go ahead and take a look at how I'm going to do that. So liters, X, line, liters, moles. Remember, I'm a big fan of writing that, letting the labels do the talking. So X line, liters on the bottom, moles on top. The number for moles is always 1 because that's our unit equality, so always 1. The liters, 22.4 is my conversion number. Now I'm going to simply divide and get my trusty calculator again. I have 101.4 divided by 22.4. The 22.4 is in the denominator, so I'm going to divide. 4.53 moles of CO2. Now I want to convert that to grams. I'm not quite there yet. I'm at my hub. So X line, moles, grams. Notice X line, X line, X line, and then I label. I let my labels do the talking. 1 for the number of moles. It's always 1. Grams, well, for CO2, I have to look it up on the periodic table. Carbon is 12, there's 1 of them. Oxygen is 16, and there are 2 of them. So that's 32. I'm going to add that up. I get 44. So my number for my conversion here is 44. So I still have it on my calculator. I'm just going to multiply it by 44, and I get 199.2 grams of CO2. Okay? And that certainly makes sense because I have way more liters than 22.4, so I have more than 1 mole, and I should have more than 44 grams as well. So there's the X lining allowing this conversions to happen. Okay? Now if I said, notice I put A, if I wanted B, how many moles of CO2? Well, I've already got it. It's right here, CO2. Okay? If I wanted to know how many particles, and I should be more specific, I'm going to go ahead and erase that particles. I'm going to say molecules of CO2, because it is a molecule, CO2. Then I go back to that moles. I'm going to use that moles because that's our hub. 4.53 moles of CO2, X line, moles, labels, I'm just doing labels, molecules, 1. It's always 1 for moles, and then 6.02 times 10 to the 23rd. So again, if I get my calculator out here and type away, I get 2.73 times 10 to the 24th molecules of CO2. And there would be my answer. Notice I put my boxes right around my answer, nice cleaned up. All right, so that's a multi-step conversion. Pretty straightforward. It's using the labels, using the X line to let me do my work for my unit equalities.